that is still being sort of put together in November, or sorry, it's in December now. It's called F# in Finance. I've already brought it up in previous meetups, and I feel like I should plug it every time we can, because first of all, we need people who are in finance and using F#, so if you and your friends, or any of your friends, or anyone that's pretty good at speaking that uses F# and something closely related to finance even.
They could also be colleagues, they don't have to be friends.
That's true, you can be us, but. So yeah, that would be awesome. Just get in contact with me or with Andrew Shepard. His email's up here. It's ajtshepard@gmail.com. The other thing is Paul's going to talk about.
Awesome, thanks, Rick. So this Saturday we are doing we're having our inaugural New York F# Community Code Sprint. Not having a very large group of people. We're going to be at Baird Rock, which is located, their offices are located in the Empire State Building. It's going to be all day this Saturday from 10 till about 6-ish. Don't feel like you have to come all day. You can stop by for a couple of hours, whatever. If you've got a project you want to hack on, you want to get some feedback from people on presenting, you want to contribute to an existing community project, we've got 5 people committed now. We've got 7 more spots open. So the only thing I would ask is, if you want to come see me after the meetup's over tonight and give me your name and your email address, and I'll give you the address and everything else. But just the only thing I would ask is, we definitely want people to do this, but only sign up if you're really going to come, because, like I said, space is really limited, because we can only fit a few people. So we've got about 7 spots left. So there's that. It's going to be a mix of coding on a whole bunch of different stuff based on whatever you don't want to hack on when you get there. But it's all going to be for the benefit of F# and for the benefit of the F# community. And that's this Saturday. So
basically, we have a couple of bugs that we don't want to fix in our open source project,
and a lot of things need documenting. A lot of things need documenting.
Don't tell them that.
Yeah,
I like doing.
I don't want them to come and then feel bad because we want them to fix bugs. Now, there's a couple of interesting open source projects that would definitely need more contributors. So, and it's a nice way to get sort of some interesting experience with F#.
And if you have a lot of fun with it, you could always come back to the user group in later months and present about it, since we always need speakers. But I think that's it for announcements, so we'll turn it over to Tomas.
Thanks. Okay, so I tried to come up with a joke for the title, and I'm not sure if it worked. Who thinks it worked? Cool. Thank you very much. There's 3 people who understand my joke. So the talk is about F# for the win, which is F# for the web. That's the point of the joke. It's regular expression, or maybe something like regular expression, I don't really know. I don't use regular expressions for parsing HTML. Bad things happen. So I'm sure when I was here last time, I had exactly the same slide. I'll still have it here. I'll say different things. So I guess everyone knows about F# Software Foundation. It's been started roughly a year ago. It's sort of, the idea is to bring different people around F#, different commercial users, different open source contributors together. The most recent interesting thing is that F# Software Foundation has this idea of technical working groups, where people who are interested in F# work together in fairly small groups on some specific subjects. Like there's a working group dedicated to F# data science and machine learning, which is a bunch of people working on or contributing to things like the archive provider, libraries for working with data. There's a group dedicated to improving the communication about F#, writing articles, getting the right web presence, PR, and so on. So if you're interested in actively helping F#, definitely check out the working groups, find something that interests you. There's a working group for F# in finance as well. I guess the motivation for joining is that you'll get early access to various ideas. I know there's been some people interested in the type provider for Bloomberg, for example, in the finance working group. So if you want to see what's happening and contribute, then check that out. So back to the actual topic of the talk. I'll talk about two things broadly. One is the data, the second is the web. So it will be a mix of F# type providers and how you can use them in different ways in the web context. How many people have played with some F# type providers already? Yeah. How many people haven't heard about F# type providers? Okay. So I'll just quickly go through the general intro because maybe that's a slightly different perspective. How I think about type providers and accessing data. Well, when you look at the various data sources that are available, my favorite one is the World Bank, which has something like 8,000 different indicators. I think there's probably more because it's not quite up-to-date data, up-to-date screenshot. There's something like hundreds. There's a couple of hundreds of countries. There's thousands of data sets available about the countries. So really, the data you can access from your programming languages it's really big. Now, when you use something like Google, when you're just searching, you actually get pretty good experience. I was looking for the population of London, and I sort of started typing, and it actually shows you the exact result you want to get immediately. But that's not really the experience you get when you try to call some REST API from C#, because you have to create a project, you have to import some nice JSON parser or write some data contract stuff. So really, I think this is the idea of type providers. You should just be able to get your data by writing maybe one line and then dot. So let me show you how many people have played with or have seen the World Bank type provider. Pretty much everyone? No, about half, which is good. So I'll actually start this one from scratch, and I'll need to do some magic to make the fonts visible. So if I do things in the right order, then that should hopefully work. So I'll start with a blank project. I'll actually create a project because I want to use NuGet, so I need some context where I can reference things. And the nice thing about F# is that it gets all the goodies of .NET. So we can use all the standard tools like NuGet to get our packages. And I'll search for F# data, and probably need to do it here. Nice. So F# data is a library with type providers for accessing various things. We'll see most of it today. So I'll need that. And I'll also want to do some charting. So I'll download another package. This one, it's fairly simple charting library, a wrapper for the .NET WinForms charting components. So nothing super fancy, but it will work fine. And now, as a next step, let me just go to the packages and I'll need to reference F# data DLL. So this is all I have to do to actually get it to work. I think there potentially could be a bit simpler, but it's not too bad. And now we can open F# data, and here's my type provider. So this is a type that's not actually a normal type. It's generated based on the metadata that the component gets from the World Bank. So when I do this, I need to reference all my code. When I do this, I can go to countries, and now I can explore all the different countries currently available in the world. So United States, surprisingly, still there. Good. We can look at the capital city. It's there. And the indicators property, that's another generated thing that gives me access to all the data sets that are available about countries in the World Bank. So we can have a look at the central government debt. It actually isn't that much fun because the data isn't like in minutes or they only have one number for a year, but still we can print the data. So there's and it ends in 2011. So we'll need to get better data source later on when the government starts working again, and we'll have some data. Right. So what did I want it to do next? I'll need another reference. So me get this. I think so. The interesting thing about this style of working with data is that you can really easily, with just a few lines, get some interesting data, and you can really easily visualize it, explore it, without even sort of starting a new project and running some application. We can do all that interactively. So I'll make it a little bit more interesting. I have a list of countries, randomly picked interesting countries. Just renamed my variable. So the interesting thing is that F# is statically typed language, and all the types actually, even though they are generated, they actually exist, and the compiler knows about them. So we can create a list of countries, which are some generated types. We can iterate over countries. So if I do first C in countries and C dot, then again I still have the information, so I can get the central government debt. And what I did right now is that I'm actually creating an array or a list of charts, which ends up creating lots of windows. That's not exactly what I wanted, because I missed the last line, which was using chart.combine to turn all the data into a single chart. So fairly easily, I downloaded data for different countries, showed that in a chart. If I added legend, then it would actually be nice and useful chart, which is left to the reader as an exercise. So to keep you engaged. So that was basic example of type provider. The interesting point there is that the type provider, the types can actually reflect the current state of the world. So if I wrote some script and the US government decided that they don't want to do it anymore, and actually US was removed from the World Bank data set, then when I open the script in a year and the country isn't there anymore, then it will not type check. And that's actually pretty useful, because it means that when you open the file again, you immediately see that some of your data sources no longer have the right structure. You'll see it earlier rather than when you actually run the program, and you'll get some runtime error. But it's an interesting problem, and the type providers can make this work better by using various sorts of caching. But it's something to think about when you're looking at type providers, because the types really depend on what you give them as the input. One thing that I'll need later on in the talk, so I thought I could do it right now as well, is to use asynchronous workflows. You could see that when I actually wanted to do the chart, it took some time, and I did it sequentially, so it wasn't too efficient. So how many people know about F# asynchronous workflows? Pretty much everyone. Very good. So how this fits with the type providers is that when you have a type provider, you can also use these static type arguments. So I need my intelligence, otherwise I can't do anything. Let me just type this. So what this is doing is that I'm telling the type provider, generate me a type that only has access to this specific set of indicators. And the interesting thing that you can do is that you can also write a type provider that can be tuned or configured in various other ways. So what I'm doing now is that I'm telling it I want to generate types for accessing all the data, but when I get the data, when I do the call, I want that to be asynchronous. So with this change, countries is it doing what I wanted? Oh yeah. So countries are still retrieved at the compile time, so that's the same. But the interesting thing is here, and I will actually get an error saying I can't chart the data because this is now an asynchronous. It's a list of asynchronous computations that will download the data. So by tweaking the settings of the type provider, I turned it from code that actually downloads the data to code that gives me some asynchronous computation that I can compose, maybe run them in parallel, and if I write one more line, then what this is now doing is that it's creating a list of all the downloads. It's composing them into a single one that will run everything in parallel, and it's running that single download and then building the charts. So if you have a nice type provider, you can use it really nicely with asynchronous workflows. Basically, when you have a type provider, there's really various interesting ways to tweak it. So that was basic intro to type providers. I guess the thing to remember is that there's the F# data library, where which has type providers for various web-related data sources. We'll see more of that later, and that's in addition to the standard type providers for SQL, web services, and so on, which are available in F#. So if you search for F# data, you'll find that. Now the second part of the talk is the web. This thing is what I found on the internet when searching for the web. So this is how web looks. The web and F#, it's actually, you will often hear people saying F#, that's only for like financial computations, for some mathematicians, and some really crazy clever people and scientists. But F# is actually really nice for doing client-side programs as well. It works pretty well. On the web, it's really nice for writing the model and the data analytical components. There's actually this book which is pretty much, it's the only F# book that's focused on a specific topic. So if you're interested in F# and the web, then Daniel Moll's book is recommended. And what am I going to do now? Well, first of all, I think people sometimes think that the web applications are the only thing, but I think when you look at average website, there's pretty much two kinds of applications. One is when you just have some content and you want it to be Google friendly, it's pretty much static. So that's for like articles and blogs and stuff. And the more interesting and exciting thing is when you have some application which is dynamic, runs on a mobile phone or on the web, and it's using some JavaScript and HTML to do the immediate interaction. So I'll mostly talk about the application side of things when you have maybe a REST API backend with some nice UI on the front end. If you want to learn, if you're interested in generating content, a little plug. I'm actually using F# for generating my blog site, which is statically generating the entire thing and pushing that to GitHub, which is surprisingly nice way to do things. But that's maybe something we can chat about in the pub later on. On the application side, there's really two things. One is writing the REST API, which is doing the business logic for your application, and the other is doing the UI. So let's start with the server side. F# works pretty well with the standard .NET libraries, so you can use it with things like Service Stack, nyc-fsharp. If you go to fsharp.org, there's tutorials how to do that. I'm going to use ASP.NET Web API, which works nicely with F# as well. And the reason for using F# in this context is that when you're doing some more interesting data processing on the server side, the F# async workflows and agents are really useful. Also, if you're accessing some data, which you pretty much are in any web application, then type providers make that really easy. So I'll switch back to the other Visual Studio, where I have some samples ready, and I'll share a link for the samples later on.
Hey, Thomas,
Yeah?
is it possible to switch your Visual Studio theme to the dark theme?
The dark theme?
Yeah.
Yeah.
The light is kind of sort of whitewashing some of the board.
Yeah, sure. I can do that. No,
but
I
it's a little too dark.
I just need to do it first here.
Yeah, that should be fine.
And then that will mess up all my fonts, but I can import my Visual Studio Dark Box settings, and that should do the trick. Nice. So what I did before is that I created the project because when you create an ASP.NET MVC Web API project, it downloads like 60 megabytes of stuff from NuGet. I didn't want to do that over the network, but there's if you what did I just do? I hit the button to build everything, so it's building stuff. If you want to create a project from scratch, the best way to do it is to go to online templates and search for something like ASP.NET F#, and you'll find various templates which give you really basic template with all the sort of links, references set up. So you can start with something like this and just write your F# code. I think this is the one that I used in this project. So I have two different projects. One is the Web API F# library. The other is a C# website project. I'm using C# website project because it's probably the easiest way to do it. You can write it purely in F#, but I think it's perfectly reasonable to combine multiple different languages. So in my example, the website is really trivial, and it doesn't really contain any C#. It just contains 5 lines of JavaScript that when I click on one of these data sources, it generates a chart. The chart is generated using the Google Charts API. So on the front end, there's really just this index HTML with some JavaScript which says when I click on a link, we call the draw chart function, and draw chart function makes an AJAX request to the API, to the dashboard, and it gets one specific data set from the F# backend, and then I create some Google visualization data table, add the data, configure the chart, and show the chart. So I wrote some JavaScript, but we'll fix that later on. And on the server side, this is mostly just the template. The only thing that I did is that I added this file which implements my business logic. And what I want to do here is that I want to write these 3 functions to get some data, to implement some dashboard business logic. I'll just continue getting interesting data about the world. But you can easily see that this could connect to a database using a type provider and do some fancy calculation or whatever you want to do in your app. I also have this value controller, which is the ASP.NET MVC thing. So this is just telling the framework that I want to have a single REST API service which handles the GET request. There's some other binding that specifies the URL. And when the GET request comes, depending on the required data set, I call the right function and I serialize the data to something that can be easily passed back as JSON. So there's really nothing complicated happening in here. And I set it up so that I can compile the project, but at the same time I can also run it interactively. And this is something that I find extremely useful when writing code. If you have some sort of business logic, when I'm writing the code, I always want to check that it will maybe work before actually running it as an application or before actually running the tests. So this is just telling the editor that this part of the code should be run only when I do it interactively, and the module declaration is only visible when I actually build it. So I have a function that doesn't do anything, and I already have reference to the F# data. That's again just using NuGet. So let's get, or actually, since everyone's familiar with the World Bank type provider, I'll save some time and copy this from here. So I'll just need to create the World Bank data context, and this is filling the implementation. Before running the project, let's try actually running it interactively and see if it does the trick. Okay, that seems to work. So I'll recompile it, run the ASP.NET website to see if it shows nicely on the web as well. Right, so if I get population in the Euro area, this is actually showing a chart with the different countries inside the Euro. It's not the European Union, it's only the countries banked with Euro. The biggest one is Germany, then we have France, Italy, Spain. What's this tiny one? Cyprus. Anybody from Cyprus? No. UK isn't here because they are not in the Europe. Let me just copy this and implement the other one. So this is doing the same thing for the OECD countries. You could have a lot of fun with visualizing some interesting data about the world. But let me do another example, which is actually not using the World Bank type provider, because World Bank doesn't know that US is actually consists of different states. They don't know that. So we'll need another type provider. I actually had to do a last-minute change yesterday in the evening because the governmental website with CSV data about state population doesn't work anymore. But somebody has a backup on the internet. So what we want to do is that I have an offline copy of the file. This is the file. We can get it from the internet, and it has information about population of different US states. It also has some aggregates, like there's population for the whole US and for some regions, but from here it's states. So we'll need to parse the CSV file and get the data. So does anybody have a nice CSV parser around? Do I use regular expressions for that? Okay. So instead of using regular expressions, I'll use the CSV type provider. And the type provider takes a sample of the data as an argument. So if I do something like this, then this will generate a type that represents files with this format. I could actually use the local copy for the type provider to make it faster, because I don't want Visual Studio to connect to the internet each time it's type checking the file. So I'll use a local copy of the file, which could really have just five lines, doesn't have to be the full data set. And then I can use the generated type to load the data from here, from the actual URL. And I forgot to run this line. Okay. Now it's downloading, apparently. And what we can do now is that we can just go over take some time over the data, and for every row, and this is again where the type provider magic happens, we get all the column names as properties. So what I can do is that I can check whether this somewhat thing, which is inferred to be an int, if this is 40, then we'll generate a new record with row name and row, what's the name? I think I need census. This is probably what I want. So if I run this, looks like it's working. Let me run it again. So the nice thing about the type provider is that you don't really have to know much about the CSV file. It looks at the sample, it infers the type, it infers the types, and it gives you typed access to all the columns of the CSV file. So what's the biggest state in the US? A quiz?
Area or population?
Yeah, it was very.
It's in terms of population.
Jersey.
California? Yes. Our twins. New Jersey is there somewhere, but probably not on the top list.
No, not at all.
I've seen it yesterday. So.
Under any measure.
Yes.
Okay. So that's getting data. This was using the type provider, running as a normal .NET code on the server side, which works really nicely. This is probably where you can get the most immediate practical benefit from using F# if you're doing some server-side web development. So let's look at the last topic of the talk. Let me actually check, when am I supposed to finish? In 15 minutes? Or do I have more?
You have 45 minutes.
45 minutes, awesome. So I'll actually use all my samples. So the next 45 minutes will be about what the cool people are doing, and that's translating F# to JavaScript. I just want to point out that F# was doing this before it was cool. I worked on a project which was abandoned in 2007, which was translating F# to JavaScript. It used Codeplex, so it's really ancient. But that's not interesting anymore, so don't search for it. It doesn't compile because it was using F# 1.7 point something. There's two interesting projects that are relevant these days and that have much more modern website and actually work really nicely with the current version of F#. Do not try to the new projects don't try to integrate with ASP.NET Web Forms, which is really good idea. So one project that I'll be using in this talk is FunScript. You can go to funscript.info, play with it. It's open source. It has Apache 2 license. It's fairly lightweight and extensible, which is what was interesting for me because I could easily extend it and tweak it and so on. So I'll show you a sample and then I'll say more things. I'll give you links to WebSharper as well, which is the other interesting project in the area. But I don't want to keep you with the PowerPoint slides for too long. So you can actually follow me as I'm doing the sample because it's available on the FunScript website. So what I want to do now is that I basically want to do the same thing as this, but without any server side. All running on the client side as JavaScript. So I have a project set up already. Again, I'm just trying to save the network. You can get it from NuGet. I think the TypeScript package has recently been updated or will be updated really soon. This is pretty much my basic template. So let's see what this does. The only interesting thing, well, there's two interesting things. The first is this reflected definition attribute. Who has seen this before? So what this does is that it tells the compiler to store a quotation or an expression tree of the whole file in this case, or of the whole module. So when you compile it, it does compile the project and generate the code, but along the way it also saves all this code as a nice AST, as a nice sort of data structure representing the code in resources. And when we run the program can look at the code and do something interesting with it, like translate it to JavaScript. The second interesting thing is this. So this is another type provider, and it's a type provider that you can use in FunScript to interoperate with JavaScript libraries. Let me open the file that was mentioned there. This is from Microsoft's TypeScript project. Microsoft has this TypeScript language, which is only interesting because they have a format for annotating JavaScript libraries, and they annotated quite a few standard JavaScript libraries, or the community has done that, and we can steal that in FunScript. So the idea is, this is a file, you can find it on the internet, which annotates JavaScript standard library with type information. So for example, there's alert function, which is in window, takes a message, which is a string, returns void, and so on. There's a new version of TypeScript, which has more features, supports generics as well. That's not currently supported in FunScript, but it will be hopefully pretty soon. If you want to help, come on Saturday. But we have a working parser for that already, so it's just a matter of updating the code generation. So what the type provider does is that it looks at the file and turns it into a nice F# wrapper. So when I say lib dot, I'll get access to all the JavaScript types. There's some values as well, so I can use window, alert. You can also set the alert variable, which wouldn't be very useful, but it generates mapping that lets you do all nasty things you can do in JavaScript. So I can call alert. If I try to do something like this, then F# is statically typed. It doesn't let you do that. So let's say hello world. Now, when I run this, it's actually running a simple launcher. So what just happened is that I started the project, it compiled the file, and when I run it, it generates the JavaScript just as a JS file. I'll show that in a second. And then it started a simple HTTP server that's serving this just for debugging purposes, so that I can easily test it. But there's no F# code running anywhere aside from the HTTP server serving the static file. I can actually just kill this and go to the output folder, which is here, and then somewhere here there's index HTML. Am I in the, yes, I'm in the right one. So that's running the code, and this is the JS file that was generated. If you want to see it, it doesn't add all sorts of unnecessary crap, which is a good thing. It still looks a bit ugly, but at least there's no like megabytes of libraries. And it's doing all the necessary encoding to make sure that your F# code behaves like your F# code and has the right variable scoping and so on. But it's not intended for reading or for calling from other JavaScript libraries. Now, yep.
On the JavaScript that it emits, is there an option to have it emit minified JavaScript?
No, there's currently no sort of minification. Maybe there will be one after Saturday.
Yeah.
I think Zach, who's the main author of this, tried running something like Google Closure compiler on it, but it crashed. So we'll need to find something that works, and then we can do it. Okay, so this isn't doing anything interesting. The interesting thing is we can, aside from doing something boring like alerts, you can actually use various nice F# features when writing JavaScript code here. We can use all the fancy F# data types like discriminated unions if you want to be able to read and understand your code. You can use asynchronous workflows, which is really nice for writing UI interactions. And we can also use type providers. So let me just copy this from the previous project. 1 second. Okay. Yes.
Do you have to do something special with your type provider to make it supported by FunScript?
Yes. You have to do. It doesn't work for free when you have a type provider. There needs to be basically a mapping. So the way FunScript works is that when it compiles the code to JavaScript, it goes through some list of mappings and tries to run the mapping to translate a piece of code. And it has mappings for standard .NET libraries that just translate that to some re-implementation of that in F# that can be compiled to JavaScript. But it can't handle arbitrary .NET or F# compiled classes. For the type providers, I had to add some additional mapping that basically translates the underlying operations of these things to JavaScript. You don't have to re-implement the whole type provider, because when FunScript sees this code, it doesn't actually see data.countries.chile, but it sees the underlying code under that, if it's erasing type provider. So you basically have to provide mapping for something like getIndicatorData function. But it doesn't work for free. Yes, so I just copied the type provider code. I have a list of countries, and I'll need to copy something else because I don't remember how to write anything in JavaScript. So let me just copy this bit of code. I'm not going to be using the standard DOM object. I'll use jQuery instead. So this is referencing the mapping for jQuery, and I'll use highcharts, which is some JavaScript charting library, which has nice mappings. So I'm importing that, and I'll actually copy this piece of code and explain it because it's long and boring. But what this does, and I suppose I want to call render at the end, and my countries, oh, this expects that countries is a function, so let's change that. And now it probably runs. We'll see in a second. What this is trying to do is that we get all the countries, and then we turn that to a list, iterate over the list using the mapi function so that we have the index of the item and the country. Country is this country object, and for every country, we'll just create jQuery input, set it to a checkbox. I'll actually show a little bit here, because the amazing thing about the import of the mapping is that you actually get IntelliSense for JavaScript, for jQuery. So when I want to set, what can I do with label? Yeah, you can append elements to a label, or I could set some attributes. There's attr, and that takes attribute name. It takes either a value if you want to set a value of the attribute, or you can give it a function, which jQuery uses for, I suppose, event handlers. So this is really just calling jQuery to build up input with the label that contains the country name, and then it picks a panel and it appends the input to one of 3 panels because I want to have nice layout. And I'll skip over the render function. We'll need to implement that, and let's just see if it actually works. If it gets the list of countries and shows them in the web page. Woohoo! So I have a list of countries. I can check them, but it's not doing anything. That's a good start. Now, well, it actually did something at the beginning. It created this blank space, which is the chart. I just need to add some data to the chart. So how do we add data to the chart? We have infos, which contains all the country objects and all the jQuery checkboxes. So we can iterate over that, and country input in infos, and we only want to generate the chart for those countries that are checked. And this is again where I need IntelliSense, because otherwise I wouldn't know that I need to do this. So if input is checked, is actually can return whatever. So we'll need to cast that. So if input is checked, then we want to get the country data. Are you still more interested in GDP or in in the government debt, or do you want to learn about education?
What's going on?
Government debt, yeah. So there it is. Central government debt in percent of GDP.
Yeah.
Okay. Now the interesting thing is, I can't actually just do this, because I configured the type provider to be asynchronous, which is fine. But the problem is, if I didn't do that, if I just tried calling it, then you can't do that in JavaScript. You can't write a for loop that does Ajax call. If I just want to make Ajax call to some REST service, I need to provide a callback that will be triggered when I get back the data. So if I actually wanted to do that, I would have to maybe use some callbacks, then wait until I get all the data. How would I do that? I don't know. So writing this in JavaScript would actually be, or even in TypeScript where you don't have async, would be kind of ugly. So let's use async, and this actually just works because, and it works because the FunScript library has mapping for standard async primitives, which don't do any complicated thread pooling or stuff, because you can't really do that easily in JavaScript. Well, you could. It just translates that to fairly simple single-threaded JavaScript. So you won't get things like real parallelism, but you will get nice callback handling for writing UI. So now we can get the data asynchronously, and I'll just uncomment this piece of code, which isn't doing anything special. It's just converting the data to a format that the highcharts library understands. And then I can call the push function on an array, and that adds a new series to the chart. So this would almost work. The only thing that I need to add is that I actually need to call render at the beginning, but then I need to set up, sorry, I'll move that up. Right, so I'll need to call render, and then I need to iterate over all the checkboxes and set up a click handler. Now render is async, so I need to do that using async start immediate, which is the function to start asyncs on the UI thread in normal Windows applications. That's the only one that has corresponding mapping for FunScript, because FunScript only runs things on the UI thread. So if I do that, then hopefully that should be my complete dashboard, and let's see if it actually works. Don't worry, I have a backup. So, woohoo! The only issue is that it's showing school enrollment because I forgot to update the string. But we are actually getting data about the central government debt. So fix that. It's a professional application, can't have silly bugs. So where's US? Here we go. Woohoo! It's going up, so that's right. That's good. In the UK, going up. Czech Republic going up. Yeah. It's pretty boring. I think the school enrollment data are more fun. Yeah. The interesting thing about Czech Republic here is that it's going up all the time. If there's a crisis or if Czech Republic is doing well, we'll always be spending more. Do we have Greece? Yeah, Greece. I think it doesn't actually have the most recent data, but I'll need to uncheck some of the others. It's asynchronous, so it doesn't hang. France. Ooh. Maybe it's negated. I don't know. That's what World Bank returns. I'm not PR agency hired by Greece.
It's the austerity.
Yeah, stuff. Okay, so you can actually find the sample on the FunScript website, play with it there, have more fun. I think the key idea is that in FunScript, it's not really trying to give you the full .NET F# experience in the browser, because that's you can do it. And I've been to the Haskell meetup last week or 2 weeks ago, where they have a Haskell compiler, Haskell compiler to JavaScript, and they basically try to map exactly everything from Haskell. And that makes really good sense for Haskell, because in Haskell you really strongly rely on how the runtime behaves. You need all the Haskell libraries to do anything. So that's one approach. What I think most of the F# projects are trying to do is to give you a way to use your favorite language for writing JavaScript applications. And they're not really hiding the fact that it's running as JavaScript, but you get some nice things like F# types, discriminated unions and stuff. Asynchronous workflows. You can get type providers to some point. So you can write a web application using JavaScript technologies, but in F#, and you can get some of the static typing benefits. I mentioned earlier that there's two main projects these days. There's FunScript and WebSharper. FunScript is the one I was using because it's sort of more lightweight, more open, easier to modify. So I could add support for the type providers really easily. WebSharper is actually doing much more than just F# to JavaScript translation. It's basically a framework for building web applications, where you can use it to. It has various libraries for composing UI elements in better ways than using just underlying raw jQuery. It has some nice F# logic on top of that for doing things like input validation and a lot more. They have the source code is available under the AGPL license, and so you can use it for open source projects as long as they stay open source. There's a commercial license as well, so you can use it for professional development. development, and they have some support for it as well. So that's sort of the more fancy commercial solution. FunScript is the VP version, but it works quite nicely. So that was a basic introduction to F# on the client side in the web. And the last topic that I want to talk about, I have 20 minutes, that's lovely, is accessing REST services. So I tried Googling what does REST mean. It stands for representation. Whoa. It stands for representational state transfer. I don't know what that means. The internet says it's a style of software architecture, which is like 2 levels of abstractions into the vagueness. But everybody knows what it means. It just means that you have your APIs available as HTTP GET with sort of nice, meaningful URLs, and they can return the data in various formats like XML or more likely JSON, and that's the sort of server side that we need to communicate with. It was hidden in the previous sample because the World Bank type provider hides the underlying World Bank REST APIs, but there was a REST API underneath. The interesting thing is, what do we do when we want to call any other REST API? So, yes, I hear you, type provider. I'll actually start with just the JSON type provider. So let me switch back to, I think I'll need to fix my broken visual. No, I don't need this. I need this one. So I'll again use F# data, and I have a snippet here already, which isn't doing really very much. It's just, so I'll switch from the World Bank theme to movies. And I want to call the movie database, which is like open version of IMDb. They asked me to register, so here's my API key. If you want to call the API and pretend that you're me, you'll have to use my key. And one fairly minor thing that's available in F# data is this HTTP type, which lets you call, lets you make HTTP requests without using the ugly HTTP web request in .NET. So you can do a request with just single line. You can give it URL, query, headers, body, cookies.
Yes, you can give it that.
What's that?
You can give it that.
Math?
Yeah.
That's probably some recent pull request. Oh, there it is, yes. Cool. But I'm afraid it will only work with put and get math. I don't think it takes real one. It also infers the math most of the time. So what I'm doing here is that I'm just calling this. I'm actually, this is using, this was written before I had it, so I'm concatenating the query string by hand, which is ugly. I could just pass it as query and then, let me fix this, not be too hard. Doing life changes to your code during demos, that's the most interesting thing. So if I do this, and I still need my API key, so I'll make that just a tuple, and I need a comma. Let's see if it still works. So I'm making HTTP request to get some data. To search for a movie, that's the REST API URL, and I want to get Star Wars, or let's make it more up to date. Did I get anything? It gives me back this, it just gives me back JSON. Don't worry if you can't see it, there's nothing to see anyway. The only thing I did is that I copied the output from the F# interactive window, copy paste, and I'll paste it into a new JSON file. So this is what the response looked like. Let me just check that there is actually something. Yeah, Olympus has fallen. It's there. So I got back some JSON. Now the reason why I'm doing this is that I want to get a sample of the JSON that I might get back when I'm calling this service. So this is my sample, and I'll save it as sample.json file in the folder where this file lives. And now I can do the same thing I did with the CSV provider, but in a much more interesting way. So I'll use the JSON type provider, give it my local file as a sample, and this is a type that can parse movies, and we can now use it and say parse data. And when I do this, I probably forgot something, so let me run everything again. Something's wrong, just restart it. Okay, so I have my movies type, I can use it, and it looks like it's doing something. It apparently parsed the data. So what's movies? Movies has some sort of entity, and I think this is a bit different than, no, it's actually right. So movies is an entity, and if I do dot, then I get access to all the properties, all the object members from the JSON in a statically typed way. Now, this would, assuming that the service behaves reasonably, this would work for any other input from the service. So I can just download some representative sample and then use it to parse the actual data I get when I search for other movies. Like if I'll show that later on. So this has total pages, total results, and page. Let's just look at the results. This is inferred to be an array. So for movie in results, do print movie title. Title is inferred to be string. I didn't run this, and I'll run this. So there's the Olympus has fallen. However, if you're looking for another movie in a related theme, there's animated movie Battle for Mount Olympus for your next flight. Right. If I search for something else, like Star Wars, I get the data. I can reuse the type, parse the data, and I get the list of Star Wars movies. So the idea is we can just get a sample and then work with it in a nice statically typed way. There's all sorts of properties like popularity, which is a decimal because it's always a number. There's release date, which is date time, because that's always compatible as a date time in the input. There's vote average and stuff. So this is one way of doing things. And I think this is probably at the moment the most practical way of doing things, because figuring out how the URLs work in the REST services isn't always the most obvious thing. You probably want to do that by hand, use the documentation for whatever service you're calling, and get some samples and generate your types based on the samples. It's still much more convenient than using some sort of dynamic approach. And if you compare the code you need to do something like this, it pretty much matches all the dynamic languages that, with the only exception that there's this additional line which generates the types based on the samples. In Python, you could write something like this, and if you did a typo, then it wouldn't work. So I think the JSON provider is a really nice way to call REST APIs. But because I have 10 more minutes, I need to show you my fancy latest pet project. And that's using this tool or a service called apiary.io. And what these guys do is that they let you document your API docs. It's actually used by the movie database. So they basically have tools for documenting and testing your REST APIs, where you write some specification for your REST service that includes sample outputs for REST method calls. They use it to generate a documentation for you. So I was using search for movie. I can even get a sample in various languages, how to call it. This is how you can call it in C#. It's ugly. This is how we can call it in Ruby. F# isn't there, so somebody needs to send them a pull request. They also have a proxy where you can write your specification before you implement your API, and they will generate proxy that behaves according to the specification, and you can start writing your client programs against this proxy to see if you can basically start writing the client against the proxy without having real implementation of the service, to see if that's what you want, if it lets you implement all the functionality, which I think is really nice. And they also do things like trace whether your requests match the format required and so on. But one nice thing they do is that they have this hidden API which you can use to get the information in a JSON format. And if you also download fsharp.data.experimental package, which is clearly indicating that this is not quite stable, but works for my samples, then there's another type provider called apiary provider, and this takes so the movie database, and this takes the name from the basically takes the name used on the website, and I'll need to give it the root for the requests as well. Now this actually uses a fair amount of network. So let's see if I can get this to work. Am I missing something somewhere? Oh. any idea what's wrong. Well, we can always restart this. I still have the backup, but I'll have one more try. Let's see if it starts working. So I reference all the things. There's apparently something wrong with my format. Maybe it's the quotes. I'm just stupid. That's it. I was trying to call the constructor to create the instance to connect to it. So that's why I had the brackets there. But what I'm doing here is that I'm just creating the type alias of this. So that generated some types. We can actually have a look at the types, but it also generated the constructor, which I was trying to call. So now that we have this, we can create an instance, and before I can do anything, I need to tell it about the API key. So there's a method on this object. The object basically represents connection to the movie database. I need to add query param API key that will be used with all the requests. So that's this. And now you can see that again, I have DOT-driven development. So there's various properties and methods, and things like collection company authentication are generated based on the structure of the REST service. So I want to do search, and I want to search for a movie, and for some methods it can actually infer the arguments, but sadly not for all of them. So I'll need to specify this using the optional argument, and my query is Star Wars. And the result is again generated on the sample, based on the sample. This time the sample is taken from the apiary.io website, where the person writing the documentation gave us a sample, so we can, hopefully it's more likely to be representative. We can again go over the results, and let's print movie title, and that's it. So this is all you need to do to query, to write a request for the apiary, for the movie database, using the type provider. And it's experimental. It can't handle all of the websites that they have there, but it can handle a fair amount of them. There's actually documentation for the F# snippets website there as well. So if I want to get the latest fssnip.net snippets, I can do that, and I can print the latest snippets. This is what people have contributed. If you're the author of the REST documentation, then you can make it work with the apiary type provider. But sometimes what people post there is that they have invalid JSON and other wrong things, which sadly we can't really do much about. So this is inferring all the information from some sort of specification of REST service, and I think there's various sort of formats for doing that, and having type providers for that would be really interesting project for Saturday. So if people are interested, I can show you how this works in more detail. So I think I'm running out of time, so I will not try writing the last demo from scratch. I'll just show you what you can do with a few more lines. And this is combining the FunScript type providers and the apiary type provider. And building, where is it? There it is. It's building a simple web application where I can search for movies. I used to do this with James Bond as an example, but then I found out that typing Bond in the movie search isn't a good idea. So these are the two movies. You can click on it and get some details. And this is all pulling data from the apiary type provider, and pretty much this is the whole main function. It creates the connection, and then over here we do the search, get results, look at the results, and for every item we extract various properties that we're interested in, add that as a jQuery HTML element, and that's it.
Tomas, just going back real quick, in that last example, you were calling async movie on the movie database.
Yeah.
Is that part of the actual movie database API, or is like that an equivalent overload that's generated by the provider?
That's, yes. So in the previous sample, I just said search of movie, and it called it immediately, gave me the data back, and it blocked F# interactive, which is fine. Here I'm using async movie. Now this is actually an overload generated by the apiary type provider. So the type provider generates both synchronous and asynchronous version. The synchronous is nice for testing, but here again I need to make a REST call in JavaScript. So that has to be done using a callback, and this is hiding the callback in F# async workflow. If I used search of movie here, then it wouldn't work because there's no way to translate that to JavaScript. Yeah. So just a quick summary. We used quite a few type providers in this talk. I used the World Bank, which is a type provider for specific data source, which is really fine-tuned to make that nice, but you probably don't want to do that for every single website, every single data source. The JSON type provider, and there's similar CSV and XML, they are really fairly general. Given a sample, you can use that to get data from a REST service or just parse any data of the same format. I think that's probably where most of the value currently is. So this is really convenient way to deal with data. I use the experimental apiary type provider, and hopefully when people figure out how to document and describe REST services, it will be possible to write something like this in a more sort of stable way. And we also use the TypeScript type provider for interoperating with JavaScript. That's another area where type providers are really nice. I'm sure everybody has heard about the R type provider, which does something similar, but for calling R. There's Rick's upcoming MATLAB type provider as well. So they would all go into this interop area. And that's it. Just the usual advertisement at the end. So I'm doing some F# trainings if you or your colleagues are interested. And we'll have this awesome F# book. That's it. Yes?
Thomas, any work on the NoSQL type providers?
Well, I know there's the MongoDB query thing in F#, which isn't really a type provider. but it's kind of related. I don't know if there's any more progress on that recently. Dmitry, do you know?
Actually, I'm working on dynamic provider for dynamic, but actually challenge in general for most non-SQL data sources, they have no schema, so it's kind of pointless.
You have to infer, that's why I love the type provider, would be an interesting way to look at the data and then
Yeah.
the type provider.
I think, so there's been some work on the sort of more academic side on the type provider for the semantic web, RDF.
That was my next question. Is the
Which,
idea.
and they made some progress on that. It's looking really interesting, but it's pretty challenging because RDF has some schema, but nobody really uses it. So I think they have a version that uses the schema, which is nice for some data sources, but it's fairly challenging to infer the schema from something which is sort of as huge as NoSQL database in general or RDF.
Who's working on the RDF one? Is that-
I can find the names. Yeah. So yeah, I think for NoSQL, if the type provider can in some way take representative JSON responses, then we could just use the JSON type provider. It would be, I would really be interested in sort of working on that with someone who knows more about NoSQL databases than I do. So, Saturday. Okay, any other questions? Yeah?
For FunScript, how is it production ready? Can you write big websites in it?
Well, people are using it in production for some things. There's Android or iPhone game written using it. I guess it depends on what do you want from your big website. If you mainly want to call standard libraries, then it should be production ready by the time it has the new type provider. If you wanted to do some more fancy things, like use fancy.NET or F# libraries, then there might be some more work to do.
It's not so much usage of .NET libraries. Like, is there any aspect of the logic that it cannot translate well or efficiently at this time?
I think that, so the biggest problem is that it generates ugly JavaScript, which can be painful if you need to debug some things. That's probably the main sort of conceptual problem. There's various sort of type minor issues that some mappings are missing, and so there are a few bugs in there, but I found the source code really nice and really readable. So if you're willing to spend some time on actually understanding how that works, then I think that's a fair answer. If you're willing to spend some time in looking at the internals, see how it works, so that you can fix some of the minor issues, then it's fine. If you want something that's sort of ready out of the box, then I would go with FunScript. Yeah, we can continue that discussion in the pub. Maybe somebody else has some experience with FunScript. I know Paul has tried it.
Yeah, the only problem I found with it was what you talked about how the type provider isn't up to date with the latest version of TypeScript.
Yeah.
But I was also only doing standard JavaScript calls and working with like really popular, real basic JavaScript.
Yeah.
I wasn't trying to do anything terribly exotic either in terms of F# or JavaScript. So, but I found in that context totally usable. totally
It works
worth it.
with jQuery and jQuery UI also.
I did not try it with jQuery UI, but I was originally working with jQuery, D3, and Angular, and a couple other smaller jQuery plugins without any problems. And then Angular, then I upgraded the TypeScript definition for D3, and that sort of was that. But yeah, but the most complex F# thing I was doing with it was some asynchronous calls. Nothing terribly exotic.
Yeah, have a look at the website. You can play some Mario as well. So, where's my picture? No, it's broken. I probably disabled JavaScript in Internet Explorer, so it's smart to be safe. Okay, any other questions? If no, or if later, then thanks for coming.
Thanks to Tomas, everybody.